Good morning to all.
Good morning to all. Very good morning. How are you?
I am good, sir.
Good. Very good. Very good. That's very great. So today, yesterday, previous class, what we did? The previous class, what we did?
We started with the chapter, sir.
We started with a chapter, and I guess we did some basic thing. And today we're gonna do the law of conservation of mass. Am I right?
Yes, sir.
We did the law of conservation of mass or not?
Um, Law of conservation of mass. Wait. Um,
Just give me a second. Let me check with the. Yeah. Can you see that? So we did the law of chemical combination. No, we did the law of conservation of mass. First, we did the law of conservation of mass, in which we learned that the mass cannot be created nor be destroyed, but it can transfer from one thing to another thing. For example, it can be transferred. For example, that mass can be dissolved in the water, transferred to solid to the solute part. Got it? In the solution part. So basically, the total mass of the reactant side is always equals to the total side of the
product side.
product side. We can also make it understand it like that the evolution of gas is there. That evolution of gas makes the, like for example, we did one reaction. So I'll write one reaction for you. The reaction is um, which are the reaction. It's, for example, CaCO3. So when you will heat the CaCO3, it will make calcium oxide, which is a quick line, and carbon dioxide gas will come. Did you understand?
Yes,
So
sir.
sometimes when this carbon dioxide gas, which is releases, it will go into the atmosphere, and then when you will measure, you will find it out some difference. But it's not like that. We have to calculate the amount of gas also. Okay, so in this, we're gonna learn all this thing about it. Did you understand?
Yes, sir.
Huh? So now, so we have first, the main topic was, like I forgot to tell it to you, the first main topic was law of chemical combination. And in this, we learn that anything which is chemically, for example, a burning of a matchstick. So here the law of chemical combination works. How? We burn the matchsticks. When we burn the matchsticks, ashes will be there. Because of that, there is a chemical change. And
Yes, sir.
chemical change means there is a chemical reaction. The chemical reaction leads to the chemical change. Did you understand?
Yes, sir.
So so under the law of chemical combination, if you will check the page number, what is the page number? Page number 5. Okay, under that there is a law of chemical reaction, conservation of mass. And what is the conservation of mass? That the total mass of the
Total mass of the reactant is equal to total mass of product. You're frozen, sir. You're frozen, sir.
law of definite proportion, or we can say law of constant proportion. Sometimes it is also called as law of constant proportion. Okay, Edric. Now, so you are writing the notes also, no, Edric?
Um,
With me.
Wait 1 minute. I'll get the pencil.
Okay, quickly. Okay.
Yes.
Now, law of definite proportion. Okay, we know that H2O. H2O is simple as water.
Yes.
Hmm? Water is like we can see there are two elements are there. When they combine together, they form a compound.
Yes.
Basically, the meaning of compound. No? So, which are the two elements? H and
Hydrogen,
O.
oxygen. Right.
Yes. Now, if I will take like this is hydrogen ratio oxygen. Okay. Now, in this case here, hydrogen and oxygen is basically there are have a definite proportion. Means we need some amount of hydrogen, we need some amount of oxygen, then only we can make water. Did you understand? No.
Yes, sir.
Hmm? For example, for example, two. If I will write, there is the ratio is 1:8. 1:8. Okay. How? If you will take 1 gram of hydrogen and if you will take 8 gram of oxygen, then only we can make the water.
Yes,
Do you
sir.
understand?
Yes, sir.
Hmm? If I will take 1 gram of hydrogen and 7 gram of oxygen, then it's not possible.
Yes, sir.
If I will take 9 gram, na, then what will happen? 8 gram will be consumed and make one molecule of water. Then 1 gram of oxygen will remain like that.
Will be unreacted.
Will be unreacted. Did you understand?
Yes, sir.
So can you write it down with me?
Yes, sir.
I'll dictate and you write it down. Okay. In a given chemical compound, quickly write it down. Okay. Put a heading of law of definite proportion and under that you have to write in a given chemical compound
Wait, wait.
in a given chemical compound. Is it Jahoan?
No, sir.
Oh, Jashun. You have to join by 10:40 because right now it's a chemistry class, secondary class is going on. 10:40 you have to join.
Senior
Okay,
second.
sir. Thank you, sir.
Senior second. Okay,
Bye,
okay. Yeah.
Jasron.
Bye, Edric. All the best.
Thank you. Okay.
Okay. So what was I'm saying? In a chemical compound, the proportion by mass of the elements that compose it are fixed. It are fixed. So it doesn't mean which mode of preparation is there. For example, if I can make the water by the thermal means by heat, and I can make the water by under any other source. Okay, the this is fixed ratio, which is 1:8.
Yes.
Okay, this is fixed ratio. Okay, if it is not fixed, then means if it is not under this circumstances, then we can't make the water. Did you understand?
Yes, sir.
Now, next law is law of multiple proportion. Law of multiple proportion. Law of multiple proportion. And I will give you a trick also. Now, this from this time, I will give you a trick, a lot of tricks. How to get the ratio? You know how to get the definite proportion ratio?
Yes. See, because it's H2O, no, so there'll be two for the like for oxygen, no,
Hmm.
the mass number is 16 and there's only one atom, so it'll be 16. And for hydrogen, the mass number is 1, but there are two atoms, so it'll become 1 into 2, which is 2.
Yeah,
So 2 is to
the
16,
two,
1 is to 8.
correct. So 2 gram of hydrogen reacts with 16 gram of
Oxygen.
oxygen. So if you will divide it, you will get 1:8 ratio. In the same way, can you tell me the carbon dioxide?
Okay. So since carbon dioxide is C
Carbon is 14, 12.
12, 12, 12,
Yeah.
and
Uh,
oxygen is 16. So it'll become
hmm.
12 is to 32. Uh,
Sorry, wait.
12 is to 32, which
32. Yeah.
will become 3 is to 8.
3 is. Sorry. So this is carbon dioxide. So it means that 3 gram of carbon is needed to react with 18 gram of oxygen. Okay, 8 gram of oxygen. Then only we can solve this. Okay, this is compound. Sorry, carbon dioxide.
So if three grams of carbon are there, but only 7 grams of oxygen are there, then it will not react. But
Yeah,
if
then it won't react.
but if three
Correct.
grams of carbon and 9 grams of oxygen are there, then it will react. But 1 gram of oxygen will be unreacted.
Unreacted. Perfect. Now we have carbon monoxide. Can you see that? Now the carbon monoxide. What is the ratio of carbon monoxide? 12 is to.
12 is to 16, which is 3 is to
And if
4.
you 3 is to. Now see, the thing is, you said that if it is 3 and 7 is there, then it won't react. But it will react. Why? It will make carbon monoxide. Did you understand? No.
Oh, because it will make carbon monoxide, but 3 grams of oxygen will be unreacted.
Unreact. Okay. So this is called as law of multiple proportion. Same compound is there, carbon and oxygen. Same compound is there, carbon and oxygen. But they have different ratio to make a different compound, not the same compound. Are you with me?
Yes, sir.
Hmm?
Yes.
So this is called as law of multiple proportion. That same elements can have fixed mass number ratio to make different compounds. Simple as that.
Yes.
Okay. So will not like you can write it down when you can leave a space on page number 6. There is a on bold letters. There is written as law of multiple proportion. Can you mark it? Can you write it down after the class? Can you see it? Or you want me to dictate and you have want to write right now?
Where is it, sir?
It's page number 6. Is it with you?
Yes, sir.
So you want me to write it down, or you want this, sir? I can write it down after this class.
I'll write it down now.
Okay, perfect. So then I will get write it down. The law states that quickly write it down. The law states that when two elements form more than one compound, when two elements form more than one compound,
Yes.
the masses of one element, the masses of one element in these compounds
Masses
are
of the mass.
masses of one element in these compounds for a fixed mass for a fixed mass of other elements are in the ratio of are in the ratio of small whole number. Small whole number. Betya, time is 10:40.
Okay.
Okay. Hi, Betya. Bye.
Hello.
Okay, perfect. Did you understand?
Yes, sir.
Okay, so now the law of multiple proportion is very important because many validity of the theory is dependent on that only. Okay, now put a heading Dalton's atomic theory. Dalton's atomic theory. So Dalton's also gives some of the theories which at that time was correct, but after the discovery and after the more experiment and all, we concluded some of the things are wrong also. Are you with me? Did you
Yes.
understand? So we have the page number on page number 7. Take out the page number 7. Can you read the all these 5 points? We'll not go and read each line, but we'll go and read the main points, okay? Which can come in your exam. And I think one more thing. Here, even the bifurcation is there in senior secondary, the bifurcation is there, but I'll not. But means we will cover whole chapters, all the chapters.
Even the TMI portions also.
Yeah, because the thing is the chemistry which you are going to do, it's dependent on the previous chapters also. Now, if you will miss that chapters, the 40%, I guess the 60% gonna be hard for you
Oh, okay. So,
because they are interlinked. Now the
oh,
chemistry is interlinked. Okay, so then it will be very difficult. So we will try to minimize the 40%, but I make sure that you should understand that. It will come into your next, like when you will go for the college, then it won't be a problematic for you.
sir,
Yes,
since I'm writing the exam in next October, right?
yeah. So we'll try to cover the course by the next
August.
September.
August.
Yeah, September or August.
August 31st next year.
Yes. Okay.
Okay, sir.
Okay, perfect.
Because
So we'll read
September,
this.
because September is the practical exams, no? So finish it by August, sir.
Yes, yes, sure. Okay. So can you read this points? Matter.
Okay. Matter consists of indivisible atoms.
So you can put a small cross that it was now means we are not following this line because it is given say that it's an indivisible atom, but atoms also has now the subatomic part which is electron, protons, and neutrons. At that time it was not discovered, but now uh, we are not following this indivisibility of atom. Did you understand? No.
Yes. Yes, sir.
Okay. Next part.
All the atoms of a given chemical element are identical in mass and all other properties.
Yes. So in elements, like Fe is the element. In this, the atoms of that elements will be the Fe. Okay. There is no some mixture will not come. Element means pure form of atoms which are related to them. Next.
Different chemical elements have different kinds of atoms, and in particular, such atoms have different masses.
Yes. The yeah, different chemical elements have different kinds of atom, and in particular, such atoms have different masses. So means if different elements are there, for example, Fe element and cobalt element, Co and Fe. So they both have different elements. So different elements means they have different their masses. Okay, that
Yeah.
is why they're different to each other. Next.
Atoms are indestructible and retain their identity in chemical reactions.
Put a bracket in that and write law of conservation of mass. Law of conservation of mass. So
Sir,
means the law of conservation of mass came from the fourth point. Yes.
but you know what? You know uranium, but uh, uranium is like not yeah, okay. Like it can be changed to another atom by like decaying or something. So atoms are not indestructible. Atoms are not.
Yeah. So means it's like a by fission we can say that uranium is changing that into a different world, but it's a some chemical reaction which is going on. Okay. So it's that is nuclear reactivity, which is this is a different topic than that. Okay.
Yes.
Next fifth point.
The formation of a compound from its elements occurs through the combination of atoms of unlike elements in a small whole number ratio.
Correct. Correct. Why? Because the thing is, uh, we learn about that only the law of constant proportion. Yes or no? You can
Yes, sir.
write on the bracket law of constant proportion, which is the minimum. Okay, so I'll read this. Dalton's fourth postulate is clearly related to the law of conservation of mass. Correct. Every atom and element has definite mass. Also, in chemical reaction, there is a rearrangement of atoms. Therefore, after the reaction, the mass of product remains same. Rearrangement. Yes, this is the correct word. What is a rearrangement? Means what happens? Like if I will, if we have this, for example, can you see that? Like here, the CO3 is there. Correct? Now
Yes.
what happened? That one C and like if I will divide it, it's gonna be look like this CA and then uh, uh, like CA, one is O and then CO2. So what happened? This CO2 get detached. Gonna be look like this. and this CO make a bond. So here, this is rearrangement. Okay, the atoms are rearranged from one place to another. Did you understand?
Sir, like how you told in the 10th class that HCl plus NaOH gives NaCl plus H2O.
Yes. So the Cl and Na got a point, and then H and OH makes the H2. Did you
So, sir,
understand?
um, so in that reaction, Na and the Cl make a bond, and H and OH also make a bond, right?
Yes. H and OH makes the bond and makes the H2.
Yes, sir.
Okay, next one. This paragraph is important. You can put a star mark on that. Dalton's atomic theory not only explained the law of conservation of mass and the law of constant proportion, but also predicted the new ones. He deducted the law of multiple proportions. The law states that when two elements are fixed issue, we learn that. So means Dalton's atomic theory that it's like a prediction. Like Dalton's, which right now we are learning in the theory, it was a predicted, and he predicted the law of conservation of mass also, law of definite proportion also, and law of multiple proportion also. So if in a question, it is come like that, then what the contribution of the Dalton is there in the chemistry science? It is like that. Dalton's predicted the law of conservation of mass. Second, the law of multiple proportion and the law of constant proportion. Did you understand it?
So, so I stated the law of multiple proportions, the law of conservation of mass, right?
And law of constant proportion. These three laws. He just give the some ideas regarding that, that it happens.
Yes.
Correct? Did you understand?
Yes,
Clear?
sir. Yeah.
Perfect.
Yes,
Now,
sir.
what is atom? We learn about the atom. Will not read this paragraph. Like atom is like the smallest part of the matter. What is molecule? Two or more atoms are yes.
Two or more atoms of either same atom or different atom because it's molecule, it's not a compound. A compound,
Yes.
it has to be two or more atoms of different elements.
Different elements.
But
Perfect.
molecule can be like
Different elements.
H2, H2O2, uh,
Yeah. That
N2, F2, Cl2, Br2, I2. It can
correct.
be the same element also.
Correct, correct, correct. Very good. So now molecules are held by the some forces. That is like covalent bond can be there. That can be a coordinate bond can be there. That can be a ionic bond can be there. So we can understand that the molecules are the held together by the some chemical forces, or we can say the chemical bonds.
Yes,
Did you
sir.
understand? For
Yes, sir.
example, hydrogen gas H2. H2 is made up of we learn in the 10th class also. They have the which bond between them?
H2, there's a covalent bond between them.
Covalent bond. Means there's a sharing of them. Now
Yes.
there are some of the like molecule we used to say, but if I will say diatomic. So in the chemistry, remember this thing: di means two, atomic means two, atomic means atom, and molecule is molecule. Diatomic means any molecule which have two in them. So for example, if I will write H2, so this is diatomic, means two atoms. Now can you give me the example of triatomic?
Triatomic triatomic is CO2.
CO. Yes, one of the carbon and two of the oxygen. So one plus two is five. So this is triatomic, then polyatomic, and then we have many. Then we learn about the elements. What are the elements? So you can yes,
Elements are the atoms that have same atomic number and same mass number. Like for example, two iron atoms or two cobalt atoms or
correct. Correct, correct. So you can underline this thing. I am reading the elements paragraph. Substance can either elements or compound. The element is a substance which cannot be separated into simpler form by chemical means. Okay, so there are 118 elements that have been positively identified. 83 occur naturally on the earth, and others are created by the scientists by a nuclear process. Okay, so 83 out of 180, 83 are the naturally one, and out of that, some of the are artificially.
uh,
Correct. Next, yes, beta.
So 83 elements are naturally occurring, but the remaining 35 elements are created by us.
Yes. Okay. So can you see that we have some name and symbol?
Yes,
Oh, tungsten is W, capital W. Wow. What is the name, Latin name of tungsten? You know?
Wolfram.
Wolfram. Very good. Yeah. And mercury is
Hg.
Hugelium. No, no. Latin name.
Hydra.
Hydra. Okay. Okay. Very good. So in test question 1.1, as obvious, there are some things. I mean, you can do it as a homework. Okay. Very easy. You can write it down the names in front of that only. Very small, small names. Okay. Then we learn about this. Now we will learn about the relationship between mass and numbers of particles. Phase number 2.
Okay,
Now the real chemistry will start. I mean, the now chapter will start.
now I
Phase
think
number 2.
now the real now the sums will start. All the numericals will start.
Correct. 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 So, what is the relationship between? First, we will understand what is the relationship between mass and number of what? Number. Okay. So, suppose you want to purchase 500. Okay. You
I
want
want
to
to purchase
purchase 500.
500.
500
500
screws. Tell
screws.
me.
Oh yes, screws.
Now, when you will go to the person, to the shopkeeper, when
Yes.
you will ask for the 500 screws, so he will not if you will go to the shop or like these, they will not count the 500 screws. Yes, they will count, but the rupees, the rupees that you will gonna pay, it's not based on the counting. It's not based upon the 500. It will be based upon how much kilograms.
Oh, because screws
Did
are
you
like
understand?
because the mass of the screw is like very few grams only.
Yeah. So basically, they are now collecting the 500 screws, measuring it in a kilogram, and per kilogram you have to pay. So, for example, if I will say in 1 kilogram, there are 60 screws, or we can say 50 screws for an easy calculation, 50 screws. So, how many kilograms will be there?
In 1 kilogram there are 50 screws, so there'll be a 10 kg.
10 kg. So now you are not going to pay according to the 500 screws, but you are going to pay according
According
to
to
the
10 kg.
10 kg. And per kg, for example, 2 rupees is there. So 2 into 10, 20
20.
rupees. So 20 rupees you're going to pay. So like that also. If I will say 16 gram of oxygen,
Yes.
the mass of the that thing is 16 gram.
Yes.
So how many number of atoms are there in 16 gram?
Uh, One.
No, 16 gram means it's 6.022 into 10 to the power 23 atoms are there in 16 gram of oxygen. Did you understand?
Oh, that number is it? That avocado thing number.
That Avogadro number is basically a 16 gram of oxygen.
Oh, okay, so
If,
that will become
if
1 into the avocado number, which is 1 into 6 into 10 to the power 23 atoms.
yes, did you
Oh,
understand?
yes, sir.
So basically, the thing is that 16 gram of oxygen doesn't have only one atom. Means if 16 gram of one atom is there, we can see it from our eyes. It's not like that. Like 16 gram is very heavy, no? 16 gram, why it's very heavy? Because it has Avogadro number of atoms, are there, which is
Yes.
6.022 to
1
10
into
power
the Avogadro
20.
number. 1 because this 16 by its mass number is 16. No. So it's 1
Hmm.
1 into 6. 6 into 10 to the power 23 atoms.
Correct. Correct. So, so what we can understand is the relationship between the mass and the number of particles. There is a one formula that I'm going to write. It is mass of one object or particle is mass of all identical items upon total number of. Okay, we can understand it like this. So I told you that the total gram is 20. Like 20 gram was there, Stu? Huh?
Yes.
20 kilogram was there. Now, if I will ask Edric, what is the weight of one screw? Then what will you say?
What did you say, sir?
So basically, there was 500 screws.
Yes.
Okay, 500 screws, and it was like weigh when you weigh it, it was 20 kilogram.
Yes.
If I will ask that, Edric, what is the weight of 1 kilogram? One screw, sorry. What is the weight of one screw? So, how will you say that one?
Weight of one screw will be 20 by 500.
Correct. So what is the mass of all identical items? It's 20. And
Yes.
total number of items is 500. So I will write it like this: 20 upon
500.
500. And if I will solve this, so I will get 1 upon 25, which is 0.4 gram kilogram. Sorry.
0.04.
Yeah, 0.04. Correct. Means 400 gram, no?
Yeah. Yes.
Which is
40,
very heavy.
40, 40.
40 gram. Yeah, 40 gram. Which is very heavy. Did you understand? No. So this is the relationship between. So you have to remember this formula: mass of one object or particle is mass of all the identical atoms. Now put a heading: mole.
Okay. Mole.
This is not an animal,
Ah,
or
it's
this is
rat. Oh, you're
yeah,
talking about the rat, is it?
yeah. Wait, that is. I mean, the mole is not a rat here in chemistry, or the mole. It is not like we have some people have. It's not like that. Its mole is different in the chemistry.
Yes,
The
sir.
mole is the amount. If I will say, Edric,
Yes.
you have a task.
I would.
100 gram of sugar. How many crystals are there? You have to count. So the now, if you will go and ask for the shopkeeper that I want sugar, so the sugar, the person will ask not that how many number of crystals you want. He will ask that how many kilogram you want.
Yes.
Okay, the
Zero.
kilogram is the amount of substance of the all the crystals. Are you with me?
Yes.
If you will ask for the salt, then shopkeeper will not have full time to count. Okay, I drink wants 1,000 crystals, so I will count one, two, three, four. It's not like that. He will say that go to the Agra. Okay, so what he will say? He will say how many kilogram you want. That is the amount of substance to represent the. I mean, we don't. I mean, if we 1 kg, there's a 10,000 crystal. So 10,000 crystal amount is 1 kg. We are
Yes.
representing into a 1 kg. That is the meaning of mole. The mole means amount of substance. Did you understand? So
The total
mole
mass,
is
the total mass divided by
yes
mole is the total mass divided by.
divided by mass of a first substance. No.
Yes.
Yeah. So for example, uh, now mole there is a formula, so you can write it down the mole formula. Mole is uh, uh, given mass upon molar mass.
Yes, mass divided by molar mass
Yeah, given mass
upon molar.
upon molar. Okay, this is called as mole. So, for example, molar mass is basically a molecular mass. Okay, there's little difference in that some terms. So, we are right now taking as a one. So, given mass, for example, 32 gram of 32 gram of oxygen has how many moles? 32 gram of oxygen upon uh, oxygen atom. So it has 16 gram of oxygen atom. Okay, 32 divided by 16 is basically
2 moles.
2 mole.
2 moles. 2 moles.
And the mole has their own unit, which is MOL.
MOL. MOL. MOL.
Correct. Correct. Did you understand? Say yes or no?
Yes, yes, sir. So we learned this in the 10th class, but we didn't learn the formula that moles is equal to given mass by molar mass. This formula we
Mass.
didn't learn in the 10th class, but
Correct.
the other thing we learned.
Correct. Correct. So, write one definition which I'm saying. Repeating. One mole always contains one mole always contains the same number of entities. The same number of entities. In bracket, write atoms, molecules, or particles. Atoms, molecules, and particles. David and Krishna just remain in this just for 1 minute, then we'll start at 10. So, now what is Avogadro constant?
6
We
into
sometimes write it.
6 into 10 to the power 23.
Yes. Avogadro constant is 6.022 6.022 into 10 to the power 20
Sir.
mole.
Avogadro constant is not represented by AV. It is represented by NA. By
Some in some books it's written as AB also, and some it's written as NA also.
NA. NA.
So yeah, in
Capital
some
A, capital A, capital A, capital A.
yeah, capital. We used to write small a only, but
Yeah,
yeah,
we
I
used to.
think capital A.
N
Okay,
capital A.
and into capital. Perfect. Now, if they want to ask that how many number of molecules, there's another formula. Oh, yeah. So if they will ask that what is the number of molecules or number of atoms are there? If they will ask what is the number of molecules or number of atoms are there, there is another formula for that.
Oh,
That is,
entities divided by Avogadro's number.
or we can say Avogadro number into mole. Did you understand? No.
Yes.
If I will say 3 moles means 3 into Avogadro number, which is 6 into 0.3.
Yeah. So it will
Okay?
become 18 into 10 to the power 23, which is 1.8 into 10 to the power 24.
24. Perfect. Did you understand, Edric?
Yes,
Write it
sir.
down this formula also. This formula also important. Quickly write it down.
No, I think.
And
Sir,
yes,
when
beta.
will our class will start? Like when?
Just in 1 minute. Just in 1 minute.
Okay, sir.
Just in 1 minute.
Hi, Miracle.
Hi, Edric. How are you?
I'm good. I'm doing good.
How was your 10th exams?
They went well. I was able to do in good in math and science. I got 97 in math and science.
Oh, good.
Out of 100. Say out of
Congratulations.
100 also.
Out of 100.
Done. Okay, so Edric will stop here only.
Yes.
Okay, so I hope today you understood everything.
Yes.
Okay, so we'll end this class and then we'll meet on
Tomorrow.
tomorrow only. No? Tomorrow is the class.
Yes. Tomorrow. Tomorrow.
Perfect. So physics has only 2 days in a week. Is it like that?
Physics at 10 a.m. I only have at Wednesdays and Fridays. So this class will be for me. It will be on Mondays, Tuesdays, and Thursdays.
Tuesday. So physics has two days in a week,
Uh,
and maths has 3 days in a week, or five
Maths
days in a week.
maths has three. Physics has two. This class has three, and yeah. This class Chem has three. Physics has two, and Maths has three.
Okay, okay, perfect. Okay, then I think we'll meet when? When we will
Tomorrow.
meet?
Tomorrow.
Tomorrow. Bye bye.
Bye, sir.
Bye. Thank you. Guys, just give me 1 minute. I'm here only. Okay.